Hello and welcome. Today we'll be doing Leetcode 42, trapping rainwater. It is a hard problem. The code itself, the solution, once we get to it, the coding it up shouldn't be that difficult, but coming down to the solution and coming to the most optimal solution itself is pretty challenging in my opinion, like the theory behind it. With that being said, let's just go ahead and give this a try. So, giving n non-negative integers, so only positive n's in this array, representing an elevation map where the width of each bar is 1, compute how much water is being trapped after raining. So really is imagining a rain has been imploded into our array and we're trying to calculate where in this elevation map rain is being trapped. So rain is trapped when there's two walls that sits right here. So when two columns exist, that's when water will trap. And sometimes this column will be larger, and sometimes it'll be less, just like how this elevation map. But that being said, it needs to be wedged in between something that is smaller than the other one or equal to hold water. Now, the problem is it's a little bit challenging coming up with such a solution, like programmatically speaking. So we the approach that could be thought of is one, we need to find a way to keep track of the current height, so this column, and also finding what is our max height at this point. Because what if something was larger here? So this got here and it was something like this. With that being said, I'm going to erase this a little bit and just focus on this simple example that I've got here. That being said, we are tracking this height. And then once we move along the array, we notice that it dropped. So the difference, let's say this is 1 and this is 0. The difference is 1 minus 0. And that gives us a reservoir or rainwater of 1. So with that being said, using this such example and this such idea, we can definitely have a better approach of this problem. And the way to do this is by using a, here, let me try to erase this so I can write on here. It would be a two-pointer technique, where we start at the far right and then on the far left. And in reality, the pointers will behave on their own. And what I mean by that is, like I used that example earlier where we were checking if there's water that could be trapped in this area. This could all be handled by the left pointer. And really is once we hit a point where we find that our height is less than our right pointer, we would visit the left side of the array for now and say, hey, we have visited a point where the left pointer is less than the right. Let's increment the left pointer and compare its previous height and say, hey, is there a shift in here? And if there is, we note that down and append that into the result index. So that happens on this side, and then on the right side, you will have something similar. You'll have 0 and 1, and that's the right pointer. And that's how it will be pretty effective. So with that being said, let's just go ahead and jump to the board. Where is my eraser? Let's go ahead and jump to the board. It'll make a lot more sense once I start kind of dive very deep into this example and showing some of the pseudocode that I will be writing up. So right here, like we said, we're going to be using our two-pointer technique. So we're going to have a pointer that starts at left, a pointer that starts at right. And we're going to say, hey, is the left pointer of the height value less than the right pointer? And before any of that, really, we're storing the previous value. And the previous value of the height, we can call it as max left. And then you got max right. And we initialize it at height left and then height right. And then again, yes, as long as we have our base case here, while left is less than the right. If height of the left smaller than the height of the right, we will increment our left pointer, and then we're going to try to find something bigger. Make sure we update our max left, which technically is our previous value at this point, but we want to see, hey, did our new left pointer grow? So did it get taller? In that case, we want to update it and make sure that we account for that. So max left is going to be equal to the max left, and then the height of the new pointer, and then the result, which is initialized to be in the top 0, will be incremented based on max left minus the new height. And this is where I'm going to talk here and make this, maybe we'll make more examples. So as we said here, so the left pointer starts at 0. So we have our left pointer, and then right starts at 1. Left is smaller than 1. So left is going to be picked here in this condition, right here. And then we're going to say, hey, left, increment by 1. So left is now 1. And then we're going to say, hey, is our max going to update? In this case, it did, because it went from being, at this point, it used to be 0. And now it's 1. So now we will have 1 minus 0, which, well, technically, this is actually 1 in this point, because height, the new pointer is left. Sorry for the confusion, but here earlier it was 0. So max L will be 1 minus 1 equal to 0, because we don't want to append something that we can't trap water here. Obviously, we cannot trap water right here because this left side is going to spill over. But we notice a shift upwards, so we want to append that and update our max left pointer. So again, we're going to go through the array and then say, hey, is our left pointer smaller than our right? In this case, technically we'll have this else condition that will handle that situation where if they are equal or the right pointer is greater than the left pointer, we want to do the same thing here, but a little bit opposite. So right pointer will be decremented. Oh, can you please erase? No? Okay, let me erase you. Oh, it did go away. Nice. Technology. And we have our max right. Similarly, we will do max right comparison, and then height of right, and then the result will be incremented if there has been a noticeable shift. But here it is technically not a shift, because our max is equal to the height at the point, because now this is 2, so it will be max right minus height of the right, which will be 2 minus 2, and it's equal to 0. So that being said, we're going to go ahead and carry on with this example. So let me go ahead and update this. Please go away. Thank you. So now we have a left pointer here, our right pointer is here. And now again, we're going to check, hey, is our left pointer less than our right? It is, because 1 is less. So 1 will be forced to move to the right, and it'll come down here. And we're going to notice right away that our left pointer is at 0. So our max L is technically, because it was before it was 1, and height of L, which is now 0, is 0. So in this case, let me get rid of all this stuff. So now it'll be 1 minus 0. And this is where water is being trapped. So we want to accumulate that right away. So result is now, I'm going to put this in, I'll just keep it in blue, I guess. Result is now 1. And now we're going to compare, hey, it was 0 less than 2. It is. So we're going to come down here again into our first if condition. Else, the left pointer will be incremented to 2. So max of L is still 1. And then height of is equal to 2, so the max will be updated to 2, and then the height will be still, because we incremented our left pointer, so the height of L at that point is 2, so this will be 0 because we have went up, and water technically doesn't spill, it will spill out of here, so we don't want to, that doesn't allow us to hold water, so we don't want to accommodate for that. And that's what's kind of clever about these two lines. It handles not counting spilled water. So again, we're gonna say, hey, our left pointer is now 2, and again, because 2 and 2 are equal, our right pointer will be kicked into here, and there's gonna be a noticeable drop in 2 to 1. So that's where 2 is here, and then the height of R is 1, so it'll be 2 minus 1, which is equal to 1, and now our result has been updated to 2. So we have water here. But again, the max right still stays at 2 because remember, we care about what we had before. We want to continue that to compare it and make sure that we're not accounting for anything wrong, and we're not again accounting for spilling water outside. So the right pointer has shifted to here, if this can go away, and then our left pointer at this point is 2. 2 is greater than 1, so this right pointer will execute again. So our right pointer will be height of 2, which is still the same. So the height is going to be minus 2, come down to 0. Sorry, I'm scribbling, but we're not accounting because again we have a noticeable shift in here, and water will spit out. So, and the walls are not holding water anymore at this point. So we are here at this point, and I'm going to update that, and we're going to say here, and again, left and the right pointer are equal to the same, so the same thing is going to happen, but here our max is going to update to 3. So right now our max R is 3. I don't know why it doesn't smart enough to pick that up that I'm scribbling this off. I'm going to do this. Wow. 3 minus 3 because we have a new pointer. So I'm going to come down here. So the right pointer is at 3, and then L is smaller than 3 at this point, so we're going to increment our left pointer. Left pointer is going to come down here, and it's going to be a noticeable drop. So that's where we're going to accommodate this guy now. So that's 1. So our max is still 2, but our height of L at this point would be 1. So our result will be 3. And then again, 1 is smaller than 3. So we're going to come back to this array. This will come down here. And the difference is again going to be 1. So here, oh sorry, it'll be 2 technically, because our height of L at this point will be 0, and that's when we're gonna have this giant water spill over here. And the max, we haven't found anything greater than, so water is being spilled at this, so water is being spilled right here at where L is equal to 0. And then we do see a noticeable increase here, but again, 0 is smaller than 3, so left is going to increment to 1. Oh, okay. Let me go back to that. L is going to increment to 1, and our height of L is going to be 1, but our max L, sorry if that was there for a long time ago, it should be still 2. So 2 minus 1, that is still equal to 1. So we got a 4 here. So we got water here as well. So this will come down to being 4. which I think that is the right answer if I'm not mistaken. No, it should be 6. What did I miss? Oh, sorry. Yeah, this. So this should be 3. The difference here, 2. So the difference here is 1, 1, 2, 3, 4, 5. Sorry, this should be 5. And then this is 6. So in total, this should be 6. Sorry, I definitely messed up a long time ago. And I hope that you were following along. But the core logic of this algorithm should remain the same. This is the correct path to pick this up. And we're going to jump right to Leetcode, code this up, and hopefully have something make more sense once you see the code. So let's jump right to that. All right, so we're back here at Leetcode. Let's go ahead and start coding up the solution. So we're going to initialize our result variable to being 0. Our our left pointer and right pointer first is going to equal to the height of L. Oh, sorry. I'm all over the place, I apologize. And then length of height minus 1. And then max left, max right is going to be equal to the height of L and the height of right. We're just going to initialize them at the pointers. And then while left is less than right, if the height of the left pointer is smaller than the height of the right pointer, we want to increment our left pointer and then update our left pointer to be max between max L and then the height of the left pointer. See which one is bigger, and we're going to update it accordingly. And then we're going to say, hey, result append the difference between max L minus height of L. Else, so if it's greater than the right pointer is less than the left pointer, or they're equal, let's just go ahead and add that to our less. As we mentioned earlier, our right pointer will be decremented by 1. Our max right will be equal to max right, and then the height of right. And the result is going to increment based on max right minus the height of right. Oh. And then we're going to return the result. Let's go ahead and run that code. Perfect, it passed the test cases, and we're going to submit the solution. Oh geez, I forgot to mention the time complexity of this. The time complexity, before I even look this up, it's going to be O of n, and the space complexity O of 1. Let's see if I'm not wrong. Perfect. And then O of 1. The reason why it's O of n, because we're looping it across the array once. We don't have any nested loops. We don't hold any data structures like an array or a stack. So our memory is O of 1 at that point. So hope that was helpful. I hope I didn't confuse. I apologize. I didn't pick that up on the solution on the board with the result being a 4. It should have been incremented by 6. And I know the mistake that I did was I just did not account the difference between 2 and the 0. Instead of I counted it as 1. So that's why it was a big mistake on my side. I apologize. But I hope you guys were able to understand this solution. And please, best of luck to your preparations, and have a good one.